Let's do some guided practice for L'Hopital's rule. Remember, L'Hopital's rule states that if we have an indeterminate form for a limit that's either 0 over 0 or plus or minus infinity over infinity, then the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x. Let's look at number 1. For number 1, limit as x approaches 0 of this guy. So here's where it helps to know our trig, right? If we plug in 0, we get 1 minus 1, cosine of 0 is 1, over 0, 0 over 0. So we get to use L'Hopital's rule. Remember, you do have to check to make sure that you have 0 over 0 or infinity over infinity. So anyway, we take the derivative, and we get on the top, remember, we always keep writing the limit as x approaches 0 until we plug in our value for x. Right, we're going to get, I guess that's 3 sine of 3x, right, because we have the chain rule, and that's over 1. And at that point, we see the limit is 0. Okay, so just one step. That's about as basic as a problem can get. Something a little more involved, number 2. Let's see here, we have the limit as x approaches 3 of x squared minus 3x all over x squared plus x minus 12. Well, if you plug that in, let me just make it clear that that's an x. Plug that in, and you get 0 over, 0. And, well, just looking at this one, I would just say that you could use L'Hopital's rule if you want. One thing I noticed immediately was that you could actually just factor out an x minus 3, right? Here we're going to get x plus 4 times x minus 3. And so you're going to get, right, you just plug it in, and you get 3 over 7. Now, if you wanted to use L'Hopital's rule, let's just do this in red. We could say limit as x approaches 3, and this is L'Hopital's rule. We'll do that. We're going to take the derivative, right? So we get 2x minus 3, and then we get 2x plus 1, and then you plug in your numbers, and you get 3/7. Right? So I hate drawing arrows, but like you see, I'm doing that, right? Right. So either way is completely acceptable. Choose whichever one you want. Number 3, we have limit at infinity. Now again, looking at this, there are 2 ways to do it, right? There's the way that we learned, and there's L'Hopital's rule. Let's do them both, right? Now, I hope you see that we're getting infinity over infinity when we do this. Now, the way that we learned how to do this is you just multiply the top and the bottom, x squared, by 1 over x squared. And you wind up getting the limit as x approaches infinity. This is going to be 4 plus 2 over x plus 1 over x squared over 3 plus 7 over x minus 2 over x squared. And then you wind up getting 4/3. But again, if you wanted to use L'Hopital's rule, which you totally can, I'll just write or. And by the way, on the exam, if I don't specify the method that you need to use, then you use whichever method you want. But here we have 8x plus 2 over 6x plus 7, right? We took the derivative of the top, derivative of the bottom, right? And that's how we got our answer. We didn't multiply by 1 over x squared. But here you see we have infinity over infinity again, right? And so, sorry, we're not approaching 3 anymore. I don't know why I wrote 3. It's infinity, right? So you see we have infinity over infinity. So we have to, again, use L'Hopital's rule, and this time we get 8 over 6, and that, of course, equals 4/3, which is what our answer is. So here, using L'Hopital's rule might have been easier if you understand that process a bit better than the process we learned in section 2.6, but it did take an extra step. So you should do whichever method you feel more comfortable with, or do them both if you want to check your answer. But if you're using L'Hopital's rule, just remember, you have to make sure that you have the proper indeterminate form. Okay, now let's take a look at this guy. This looks like another 0 over 0 winner right here. I'll put that in parentheses, I usually do. And that, whoops, I probably should check, but again, it's pretty clear that that's 0 over 0, at least I think so, right? 0 squared is 0, sine of 0 is 0, 0, 0, everything, literally everything is 0, right? So anyway, derivative time, and this is a little bit of an obnoxious derivative because we do have to use the product rule. Not the worst thing in the world, but you know, when we're taking limits, it's like, ugh, gotta use the product rule. But that's okay, we can do it. Right, and here, again, it's good to know our trig, and you see that we once again get 0 over 0. Annoying. Guess we have to use L'Hopital's rule again. So, oh man, this is going to be extra annoying, right? Because we've got 2 product rules on the top. Oh boy, okay. So anyway, we're going to have 2 sine of x plus 2x cosine of x. Right, just to be clear, that was this derivative. Right, that was the product rule for that derivative. And then I guess we're going to have still on the top plus 2x cosine of x. And then I guess it's going to be minus x squared sine of x. And just to be clear, this is still on the top, right? This is now the derivative of this guy. And all of this is over on, I guess it's just negative sine of x, right? Because the derivative of the bottom is a bit nicer. And at this point, we have our lovely answer of 0 over 0. Oh, so annoying, right? You see how we're still getting... Sorry, that's a little ugly right there. Let's try 0 over 0, right? So you see all the terms either have sine of 0 was 0 or 2x, 2 times 0 was 0. And the bottom, we still have negative sine of x. Oh my gosh, are you kidding me? It's okay, though. Because we have 0 over 0, we get to use L'Hopital's rule again. Let's hope. Well, you know what? We're going to be good this time. I know it because the derivative of negative sine is negative cosine. So no matter what, we're getting something over 1, right? This is a good thing. Or negative 1, I should say. But, oh gosh, how annoying, right, though? Ugh. 2 cosine of x. Okay. Plus 2 cosine of x minus 2x sine of x. And just to be clear, right, that's the derivative of that guy, right? Yuck, right? And then, again, plus 2 cosine x. Yeah, I should have combined these two, actually, right? Oh, well, I didn't. Plus 2 cosine x minus 2x sine of x. All right, same thing twice, right? I should have simplified, right? Lesson to the math professor, right? So another one. I use the same color because, again, I should have combined the two. And then, we have negative 2x sine of x. Negative x squared cosine of x. Right, and to be clear, that is this derivative. Lovely. Okay, so anyway, at this point, again, we know we're getting a legitimate answer. It's just, what is it going to be, right? So let's just, guess I'll try to mark everything that is non-zero, right? That's going to be non-zero. That's going to be non-zero, right? Because it's 2 times 1, right? But the other stuff is 0. That's 0. Yeah, I guess that's it. So it looks like we have, after all of that, oh my gosh, it looks like we have 6 over negative 1, which is negative 6. Whew. So that might be a bit long for an exam, but it is a problem you should know how to do. Okay? And number 5, ooh, that's a doozy. Limit as x approaches infinity of x minus ln of n. Now, this is a tricky one, right? If you take a look at this, right, let's see if I know how to do this one, right? You have x minus ln of x. This is one of these infinity minus infinity ones. Well, little stumped looking at this, right? Any ideas what we might do? Well, the only idea that I can think of is, remember the same way that we, again, you can look at the graph and you can see the answer is going to be infinity. X increases quicker than ln of x. But what I was thinking is, you know how we took ln of both sides? What if we tried something kind of similar here, except instead of taking ln of both sides, we did this. What? So e to the y equals, and again, because we're talking about continuous functions here, we can put the e right inside of this guy and talk about e to the x minus ln of x. Now, this is not something we covered. This is not something we covered in the notes. This is new. And then, remembering how this works, I'm just going to simplify this right off the bat. We have e to the x times e to the times e to the negative ln of x. Does everyone see that? Because remember, when your base is the same and you're adding or subtracting the exponents, you can just split them up, right? And at this point, well, I'm not sure it's clear what we have, but yeah, I think we have infinity. At this point, I think, yeah, we have infinity times something. I'm not even sure it's clear what it is. Looks like it's infinity times 0. To make it a little clearer, we're going to say, okay, limit as x approaches infinity of e to the x times, now this is e to the ln of x to the negative 1. See how I took the negative sign in front and put it there, right? I used the log rule. And then at this point, I can say this is the limit as x approaches infinity of e to the x times x to the negative 1, right? Because you notice that the e to the ln cancels. All right, let's scroll down a little bit. And then at this point, we're going to have, notice, by the way, I haven't even used L'Hopital's rule yet. Haven't even used it yet. Limit as x approaches infinity of e to the x over x, right? Because x to the negative 1 equals 1 over x. Let's just make a note of that. Right? Now I'm going to erase that. So if you want to remember that, then go back in the video, right? Now at this point, finally, we have infinity over infinity, and we can use L'Hopital's rule. So finally, we can use L'Hopital's rule, and we get e to the x over 1, and we do, in fact, get infinity as promised. Now, just to be clear, this is not quite the final answer, right? Because we have e to the y equals infinity. However, it doesn't really make a difference, right? If e to the y equals infinity, then you just take the ln of both sides, right? And you get y equals infinity, right? So that's our answer for that. Whew. A couple of tough problems here. All right, now last but not least, let's look at number 6. Limit. This one, again, also a little challenging, but maybe a bit more familiar. Limit as x approaches infinity of x to the 1 over x, right? Well, again, actually, moves over here, but we're going to let y equal it, okay? So ln of y equals ln, well, I'm just going to stick it inside the limit as x approaches infinity of ln of x to the 1 over x, right? And then this equals limit as x approaches infinity of 1 over x ln of x. And I guess really, if we want to make that even a little nicer, we can make that limit as x approaches infinity of ln of x all over x. And then at this point, we see that we can use L'Hopital's rule because this is actually infinity over infinity. Right? So using L'Hopital's rule, we get the limit as x approaches infinity of 1 over x over 1, and that equals 0. So our answer is 0, right? Right? Wrong. So y, the actual thing we were concerned about, space that a little bit more, y equals e to the 0, which equals 1. So it turns out our answer is 1.